This is section 11.2. The title is Arcs and Chords. Objectives: apply properties of arcs. Second one, apply properties of chords. This is the vocabulary that you're going to be responsible for. I'm not going to read it, but you can pause this and make sure that you know what these terms mean at the end of this section. I'm going to the next slide. Center angle. A center angle is an angle whose vertex is the center of the circle. Notice that in this case, this is the center angle that they're talking about, and the vertex is the center. The vertex is the center of the circle. Next definition is an arc is an unbroken part of a circle consisting of 2 points called the endpoints. So these are the endpoints, and all the points on the circle between them. So all these points in between them. Let me highlight several. But this is what represents an arc. More terms. A minor arc is an arc whose points are on or in the interior of a center angle. This is how you. This is the illustration that goes with the definition, and this is how you find the measurement of the minor arc, which is whatever the center angle is. A major arc is an arc whose points are on or in the exterior of a center angle. This is the illustration that goes with it, and this is how you find the measurement of a major arc. And if the endpoints of an arc lie on a diameter, the arc is a semicircle. This is the illustration that goes with it, and this is how you find the measurement of a semicircle, which is 180 degrees. More terms. Adjacent arcs are arcs of the same circle that intersect at exactly one point. They're highlighting, this picture is highlighting these two adjacent arcs, RS and ST, and this is the point that they intersect, and it's only one point of intersection. Postulate 11.2.1 is the arc addition postulate. The measurement of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So in this case, arc ABC is equal to the sum of arc AB and arc BC. Sort of like the segment addition postulate, but not for arcs. Something that you need to know. For this section, it says minor arcs may be named by 2 points. Major arcs and semicircles must be named by 3 points. Next slide. Problem number 1 says find each measure. In this case, they want you to find QS. So they want you to find this arc, and again, the relationship between this arc is whatever the measurement of the center angle equals is the measurement of this arc QS. By using center angles, I know that this is 47 degrees. I mean, using vertical angles. This is 47. This has to be 47 because of vertical angles. Now, if you look carefully at the picture, this represents diameter. So I know that these 3 angles, 47, this one here, and this one, need to add up to 180. So this is what I'm going to do to find this angle here. I'm going to take 180, and then I'm going to subtract the sum of 47 and 55. This is going to give me 102. When I subtract these two numbers, this gives me 78 degrees. So now I'm able to find the measurement of QS, which is by adding these two angles, which is 125. Part B says find the measurement of RQT. So in this case, I'm looking for RQT, RQ. Notice in this case it's a major arc. Again, this is still 47 degrees vertical angles. And then I'm going to use the fact that this is a diameter, which means that this portion of the arc is a semicircle, so it's 180 degrees. So to find the measurement of RQT is 180 plus 47, which is equal to 227. Next problem. In this case, they want you to find the measurement of VTW, which is this center angle here. Notice that I have the measurement of UTX, arc UTX is equal to 180 degrees because this is a diameter. At this point, I know that I have 180 is equal to the measurement of UTW plus 78 degrees, which is this angle here. Then I'm going to do the following. I understand that I can find UTW by subtracting 78 and I get 102. And then at this point, I also know that UTW represents these two center angles, the sum of these two center angles, 4x minus 2 and x. And then I have the following equation. I can drop the degree symbols, solve for x, and I get 20.8. I'm looking for VTW, so VTW is the center angle, which is just x, so I'm done. All I need to do is say that it's equal to 20.8 degrees. The measurement of VTW equals 28.8 degrees. Next slide. We have a more second theorem, theorem 2.2, theorem 11.1, theorem 11.2.2. There's several parts to it. The first part says that if you have a circle and congruent center angles, then the chords are also congruent. So in this case, this distance, this chord, is equal to this chord, since these center angles are congruent. The second part of the theorem says congruent chords have congruent arcs. So if this chord is equal to this chord, then this arc is equal to this arc. That's what it says here. And the last one, it says congruent arcs have congruent center angles. So if this arc is congruent to this arc, then this center angle is equal to this center angle. Let's go on to the next slide. This example says, example 3, circle C is congruent to circle J, and they're telling you that the measurement of GCD is congruent to the measurement of NGM, and they want you to find NM. From here, since the center angles are congruent, these chords must be equal because of the theorem that you just saw. So then at this point, all I'm going to do is substitute, do a little bit of algebra, and I get t is equal to 3. Once I have t, I can find nm very easily by substituting for t 3, and then I get 16 as my answer. Problem number 4 says that PT bisects center angle RPS, and they want you to find the measurement of arc RT. Since PT bisects that angle, we know that we have RP measurement of angle RPT is congruent to angle SPT. From here, by the previous theorem that you saw, we can write this statement. Those two chords must be congruent. By definition of congruence, we know that they are equal. And then at this point, all I'm going to do is substitute whatever RT is equal to, which is 6x, and TS, which is 20 minus 4x. A little bit of algebra, and I end up with x is equal to 2. Then at this point, I know that RT is equal to 12. But again, by the previous theorem, I know that whatever RT is equal to, which is this chord, it is also equal to this arc RT. So that's why I have the following by that theorem. And then you have 12 degrees. Notice that this is not really drawn to scale, but you get the point. This is the work, and this is what we get for the answer. Next slide. Problem number 5 says the circle A is congruent to circle B, and CD is congruent to EF, and we need to find the measurement of CD. So at this point, again, I know that since these two chords are congruent, these two arcs, CD and EF, must be congruent or equal. Substitute. You can drop the degrees symbol, solve for, add, subtract 25y from both sides, add 20, and this is how we get 20 equals 5y. Divide both sides by 4, and then at this point, all I need to do is the measurement of CD is equal to 25 times 4, and which is equal to 100 degrees. More terms. 11.2.3 says in a circle, if a radius or diameter is perpendicular to a chord, then it bisects the chord and its arc. So this radius bisects this chord, so this distance from here to here is equal to from here to here, and this arc ED is equal to arc DF. And the next theorem says in a circle, the perpendicular bisector of a chord is a radius or a diameter. So this is your chord. If you find the perpendicular bisector, it's going to go through the center, and it generates either the radius or the diameter. Problem number 6 says find NP. So the first thing we're going to do is we're going to draw the radius Rn. So here it is. Here's Rn. And I know that Rm is equal to a plus 7, and this is a radius. In the same manner, Rn is a radius, so that's why Rn is equal to 17. At this point, I'm going to focus on this portion of the picture here. And I'm going to use the Pythagorean theorem. And I know this is a right triangle, and I have the following. Sn plus Rs is equal to the radius Rn squared. Substitute. This is 8. The hypotenuse is 17. Do a little bit of math. You get Sn squared is equal to 225 take the square root of both sides. We end up with plus or minus 225, but since we're talking about a distance, I'm only going to focus on the positive one, which is 15. And then this is the last step. Still need to find NP. But notice that NP, by the theorem, this radius bisects NP. So this distance is equal to that distance. So that's why we have NP is equal to 2 times Sn. We found that the Sn is equal to 15. That's why the answer is 30. And this concludes this section.